Section 11.3, Conditional Probability and Events Involving AND. Conditional probability is the probability that an event B will occur given that event A has already occurred. It's denoted with P parentheses B given A close parentheses. It is called the conditional probability of B given A. Example 1. A number is randomly selected from the sample space S, which equals 1, 2, 3, continuing to 10. Event D means the number is odd, and that's our set 1, 3, 5, 7, 9. Event M, the number is a multiple of 3, the set 3, 6, and 9. The probability of D, 5 odd numbers out of 10 numbers, is 5/10, which reduces to 1/2. Probability of a multiple of 3, 3, 6, 9, that's 3 digits out of 10. Probability of D intersecting with M. Just look at D intersect M first, and that is 3 and 9. 6 is not in D, so it is not part of the intersection. So the probability of D intersect M is 2 out of 10 digits, 2/10, which is 1/5. The conditional probability of M given D. So the conditional probability that it's a multiple of 3, given that it is odd, it's the number of things in the intersection divided by the number of elements in D. There are 2 elements in the intersection. There are 5 elements in D. The answer is 2/5. The conditional probability formula. The probability of an event B given A is the probability of the intersection divided by the probability of event A, which is the probability of A and B happening divided by the probability of A. Example 2, a family has 2 children. What is the probability that both are girls given that one is a girl? Possible outcomes with 2 children are girl, 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 boy, boy, girl, and boy, boy. We're going to let A equal girl, girl, the probability that both are girls. Probability that both are girls is 1/4. We'll let B be the set that one is a girl. That's girl, boy, boy, girl, and girl, girl. At least one is a girl. Probability of B is 3/4. Probability of A given B is the probability of the intersection of A and B divided by the probability of B. The probability of the intersection of A and B is 1 out of 4. The probability of B is 3/4. The intersection of A and B only includes girl and girl. That's why it's 1/4. 3/4 is our probability of B. Dividing those, the probability that both are girls, given that one is a girl, is 3/4. 1/3. Example 2, a family has 2 children. What is the probability that both are girls given that the firstborn is a girl? We have our possible outcomes again. Girl, 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 boy, boy, girl, boy, boy. Probability that both are girls, we'll let that be A. Girl, girl, that probability is 1/4. And given that the firstborn is a girl, so we'll let B equal girl, boy, or girl, girl. The firstborn is a girl. The probability of the firstborn being a girl is 2/4. So the probability that both are girls, given that the firstborn is a girl, is the probability of the intersection divided by the probability of the firstborn is a girl. Probability of the intersection, the only thing they have in common is girl, girl, 1/4. Probability of the firstborn being a girl is 2/4. Divide those fractions and the answer is 1/2. Two events A and B are independent if the occurrence of one of them has no effect on the probability of the other one occurring. A and B are independent if the probability of B given A equals the probability of B, or the probability of A given B equals the probability of A. Example 3. A single card is drawn from a standard deck of 52 cards. We're going to call event F the selected card being a face card, and event B, the selected card is black. Probability of B, so the probability of choosing a black card is 26 out of 52, 1/2. Probability of F, so the chance of selecting a face card is 12 out of 52, which is 3 out of 13. The probability of choosing a black card given a face card is selected is the probability of the intersection divided by the probability of a face card. Just looking at the probability of the intersection of black and a face card, there are 6 black face cards, so it's 6 out of 52, which is 3/26. We're going to have to divide that 3/26 by our probability of F, which is 3/13. 3/26 divided by 3/13 is 1/2. Probability of a face card given a black card is the intersection, the probability of face card intersecting with the black card, divided by the probability of a black card. The probability of that intersection is 3/26. This time we have to do 3/26 divided by our probability of our probability of B, which is 1/2. 3/26 divided by 1/2 is 3/13. Still same information about example 3. The question is, are F and B independent? That answer is yes, because the probability of B given F equals the probability of B, and the probability of F given B equals the probability of F. Example 4. Jacqui has categorized the 20 books in her library in the table below: hardcover, paperback, fiction, nonfiction. She selects a book at random. What's the probability that the book is fiction? 11/20. The probability of fiction and hardcover, 3/20. Probability of hardcover is 8/20. So the probability of fiction given a hardcover is the intersection divided by the probability of a hardcover. 3/20 divided by 8/20 is 3/8. Are H and F independent? That answer is no, because probability of F given H does not equal probability of F. We're done. Multiplication rule for probability. Let A and B be events. Probability of A intersect B equals the probability of A and B, which is the probability of A times the probability of B given A. If A and B are independent events, then the probability of the intersection is the probabilities individually multiplied together. Example 8. An urn contains 4 red, 2 blue, and 5 yellow balls. 3 balls are drawn without replacement. Find the probability that the first ball is red, the second is yellow, and the third is blue. The probability of the first being red, the second being yellow, and the third being blue is the probability of the first red times the probability of the second being yellow, given that the first one was red, times the probability of the third one being blue, given that the first one is red and the second one is yellow. Individual probabilities of those events are 4/11 times 5/10 times 2/9. The balls are drawn without replacement. It's 4/99, which is about 0.0404. Example 9, 2 fair coins are tossed. List the possible outcomes. Possible outcomes are heads, 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 tails, tails, heads, and tails, tails. Find the probability that the first lands heads. Looking at our possible outcomes, 2 of the 4 work, and that probability is 1/2. Find the probability that the second lands heads. Again, reading from our outcomes, in 2 cases, the second one landed heads. Out of 4, 2/4 is 1/2. Find the probability that the second lands heads, given that the first landed heads. There are possible outcomes. 1/4 divided by 2/4 is 1/2. Are the events in parts B and C dependent or independent? You can see that 1/2 equals 1/2. They are independent. Example 9, 2 fair coins are tossed. It's part F. Use the multiplication rule for probability to compute the probability that both coins land heads. The chance for the first coin is 1/2 times the chance for the second coin is 1/2. 1/2 times 1/2 is 1/4. That's section 11.3, conditional probability and events involving and.